Okay, so thank you everyone for joining us. So so those of you watching remotely, this is JBug Worldwide on WildFly. We've got Jason Greene talking today, who's the project lead of WildFly. Before we start, I'm just going to share my desktop and talk about JBug Worldwide and what we've got coming up in the future. Okay, so for those of you who are new to JBug Worldwide, what is it? So the format is a user group type format. We're running sort of informal and interactive sessions. Sometimes these sessions are co-located within a physical JBoss user group, like we are today at the Newcastle JBoss user group, and sometimes they're just purely remote, where we have a remote speaker just over Google Hangouts. We cover, each month we have like a talk of kind of broad interest, what we hope, on something related to JBoss. So like today we've got a talk about covering WildFly and what's new in WildFly, so we hope that's generally of interest to people. We try and do that once every month. And then also we'll hopefully fit in between some more niche talks, which may be coming from physical user groups. So we have two talks on transactions in the cloud in August, which are kind of an example of our niche talks that we're offering. It's the JBug Worldwide was grown out of JBug Newcastle, which is where we are today. So we started off broadcasting our events over Google Hangouts, and then we kind of thought that maybe we should kind of create a global brand for other user groups to use as well, and to try and get bigger exposure. Yeah, we're still quite new to this, so we're definitely keen on getting any feedback. So we want to know how it works. And the community for this lives on meetup.com, so that's the best place to go. It's a central place for this. And there's the URL on the page, so meetup.com/JBoss User Group Worldwide. So what have we got coming up? So we have the next session on transactions in the cloud. So that'll be on Tuesday, August the 19th. We have two talks talking about some new research about how we're making some new features in Narayana that are applicable to using transactions in the cloud. And then in September we'll hopefully be having a talk on Docker, but that's not confirmed yet. So keep an eye out on the meetup page for that. Then also in September we have a talk on XPath by Rob Davies, who leads the XPath initiative at Red Hat. So XPath is basically anything, all the different types of platform as a service that's being offered by Red Hat. So here we're talking about things like workflow as a service, platform as a service, and so on. And then in October we've got a talk on Archillion, which is a new testing framework, and we have the project lead Aslak talking about that. And then another virtual user group that may be of interest to you is VJug. So this is a virtual Java user group. So their topics is just around Java, whereas we specialize in JBoss. They're also on Meetup, so you can go to meetup.com/virtualjug. They've got a talk on tomorrow, so July the 9th, on testing and refactoring of legacy code. So if that sounds of interest to you, go and have a look at meetup.com for that. Okay, so that's all I wanted to say. So let's just turn off my screen share. Just bear with me. Jason, can you switch off? Can you switch back to your camera, please?
Sure.
We can still see your slides, Jason.
Yeah, hang on. Sorry.
Oh, no problem.
Okay.
All right, hi. Well, thanks for joining us. Can you hear us?
Yes, I can hear you guys just fine.
Okay, great. Okay, so I guess before we start, it'd be good if you could just introduce yourself so we all know who you are and what you do at Red Hat.
Sure. Okay. So it's thank you everybody for coming to this presentation. about the WildFly community project, and in particular the WildFly 8 release. I'm Jason Greene. I'm the lead of the community project and the platform architect for JBoss EAP, which is our commercial offering that is derived from the community project. I'll talk a little bit more about that later. Let me just go ahead and get right into my slides here. Okay, so yeah, some other things about myself. I'm also a member of the Java EE expert group, and in general, I tend to be quite a bit of a performance nut. So I'm always looking at new and interesting ways that we can boost the performances of our project and new problems related to concurrency and multi-core computing. The main goal of this presentation, like I mentioned, is to get a good understanding of the WildFly project, and in particular the features that are in WildFly 8. I do have some material on what already exists in JBoss AS7X and also EAP. We may not get time to get into much of that, but I'd be happy to be able to pull it up in answers to questions. So to start off with, what is WildFly? Well, previously it was called JBoss Application Server. You may not be aware of this, but since we joined with Red Hat, we split off and did something similar to what RHEL and Fedora is on the Linux side, and we have a community offering that was called the JBoss Application Server project, and then we had a commercial offering that was called the Enterprise Application Platform. It generated what we felt was a lot of confusion because if you said, a lot of times people would say, well, I'm using JBoss, and it'd be hard to have a distinction between which JBoss we're using. So we decided to rename the project, and so what was called JBoss Application Server is now called WildFly. And the way this works is similar to RHEL and Fedora, where the community development happens as the upstream. It's the latest code base happens in WildFly, and then that code base then transitions into our product, where we have a conservative branch that's after we've received a lot of feedback from the community and on the new features we've introduced. It then moves into the EAP platform, and there we provide long-term support, 7 to 10 years, depending on which plan you use. And then there's additional testing and certification that we do. So basically, the big difference is that WildFly focuses on providing the latest features, and it tends to have a very feature-driven, fast schedule, whereas EAP will focus more on providing bug fixes, and when feature updates are done, they're done in a very conservative manner, where the focus is on not breaking backwards compatibility. WildFly at its core is essentially a fast, lightweight, manageable runtime. You may think of it as, well, WildFly is just an application server that does Java EE, and that is certainly its most common usage, although the architecture itself was designed to really do just about anything that you would run in a JVM environment. If you were to cut it down to its simple, tiniest core, it would be a service container that is responsible for concurrently starting services, a modularity runtime that allows you to have multi-tenancy within the application, and also a manageable runtime so that you can make configuration changes that are persisted on various nodes that you run it. So you can actually take our Java EE config and pull out individual subsystems and make it something smaller than just Java EE. But at its core, even with all of the services combined, you'll notice that it still has a very lightweight feel. It takes up a small memory footprint. It starts really fast, a couple of seconds. And it's also focused primarily on the developer. So the intention is that you're able to produce an application quickly, that it's friendly to use. But we also kind of like to have our cake and eat it too, and we focus on the developer as the primary case, but also enable you to be able to deploy it in production. So there's a lot of choices when you can make optimizations where you say that this is a development mode kind of thing, and this is a production mode kind of thing, and we always try to do to where the configuration actually works well for both use cases. It supports Java EE 7 currently, and it is committed to providing the latest version of the spec, and we also add additional frameworks that are open source for other initiatives that we have, such as Hibernate, for example, and are always looking at providing a set of APIs that best enables your applications to do what the latest technical trends are. So WildFly 8, the biggest change that we made was actually introducing Java EE 7 support. And Java EE 7 has a lot of capabilities I'll get into, but really the biggest change in Java EE 7 is that it has a lot of technologies that enable the sort of the next generation of web applications. We also introduced a high-performance web server in WildFly 8 called Undertow, and a lot of that was because of the new capabilities that Java EE 7 has, but it also was for some other features that we wanted to do, namely the ability to reduce our port usage, and we allow, so it's better enabled for a cloud platform. So like example, if you download WildFly using our default configuration, there's actually only two ports that are in use, and we use a technique where we multiplex different traffic over those 2 ports using the standard HTTP upgrade, and our web server was a part of that. We also improved some of the operational aspects of the project itself, so we have a role-based administration control and auditing feature set that allows you to sort of segment administrative responsibilities if you're a large organization and you want to have different rights as to who can control what. We have a facility for you to do that. And then we have the ability for you to do updates. The core part of the platform, for example, with WildFly 8.1, you can actually install it as using the patch command to move it from 8.0 to 8.1, and then it keeps your existing configuration and so on. And then we provide a minimalistic core distribution. And this is what I was getting back to earlier when I was saying that WildFly doesn't necessarily mean it's Java EE. You can actually have it be something very specialized or a subset of Java EE. And our minimalistic core distribution includes just those small services that are common to all runtime servers that you would have, the service container, modularity, and so on. So if you look at Java EE 7, there was a lot of updates to individual specifications, but if you look at what was actually, the big things that were added, there is support for working with JSON, which is incredibly useful. There's support for WebSockets, which allows you to do full duplex communication, and that's really great for working with mobile devices or real-time applications. There was also a really nice improvement with handling concurrent code that I'll get into in a second, where you can actually execute tasks concurrently in a manner that's actually portable and compatible with the application server. And then there's a whole batch layer that was added that allows you to do traditional batch control jobs, and you can interact with a job operator from your actual web application and control how jobs get submitted and executed. So just to jump into what a WebSocket application looks like, it's really pretty simple. If you've developed a servlet before, it'll look kind of familiar. You really just need a class, and then you stick some annotations on it. And in this case, we're basically implementing a simple chat protocol, and you have a method that you get invoked on whenever there's a new message that comes in. And when we get this message in our chat protocol, we just want to stick strings in it, so a text message, and then we want to replicate that out to all of the other clients that are currently connected to our chat protocol. So in this example, that you can see where it says session.get open sessions, and then from there we iterate through every single peer, and then we relay the message that we just received. So this is basically like IRC in a web browser, and with just a very short amount of code. You could sort of visualize more advanced examples, because WebSockets is a full duplex protocol, so you can have both the client and the server sending data back and forth in whatever format you choose to do. So anything that you would have developed in the past with, say, a standard Java application and using sockets, that's the same kind of thing you can do here, but WebSockets makes it a lot easier because you simply work with the notion of passing messages around, and then rely on the framework to handle all of the difficulties with managing the connection and the protocol negotiation and so on. And if you look at all the web browsers that are out there, nearly all of them now support WebSockets. The only issue that you run into is when you have like very old legacy browsers, and there are other strategies for dealing with those. So if you were to start developing your application today, you'd find WebSockets is a good technology to use. So leaving the web stuff and more into the batch processing I mentioned earlier, really the key thing with the batch processing is it just gives you the ability to do sort of a standard job control language. And with that job control language, you can specify different reusable components for reading and writing to your whatever data sources that you have. So like you could have a batch job that reads from, say, a text file, another component which writes to a database, or perhaps it sends an email, and then you can reuse the sort of the processing logic for record manipulation. And it does some other nice things too, like it manages transactions for you. So when you say, for example, I've got a chunk with an item count of 3, then that defines the amount of records that get processed in one group together. So you can tweak this operationally based off of your server platform. There's facilities for doing things like deciding on the concurrency level that your batch system will implement. So you could do something like say, okay, I'm going to process 10 records at the same time, and then the batch layer will automatically use 10 threads to do that, to do it in a parallel fashion. And then your code for actually implementing the reader, the processor, and the writer, they're not aware of any of this. All they're simply doing is just that one simple activity of read some records, stuff it into a list, and then process those records, and then finally write them to whatever the source is. And then the JSON API itself, if you've ever used DOM, it's very similar to that. Instead of working with the XML structures, though, you're working with the JavaScript format, and you can assemble things programmatically for the writer side, and on the reader side, you can browse the object model. Although one of the really powerful capabilities is that it doesn't support just an object model view, which requires that it all exists in memory. There's also a streaming API that's similar to the stacks APIs in Java, if you ever use those. And this allows you to basically get events every time a new, for example, a new object is seen in the stream. You can get an event and then react to it. So this allows you to do stuff like pipe, say, 10 gigs of traffic or something over an HTTP stream. Using the streaming API, you can do it without allocating 10 gigs of memory. Earlier I mentioned that there is a pretty powerful concurrency support in Java EE 7, and if you've used the standard Java concurrency APIs that were added in Java 5, this will look pretty much the same. There's only some subtle differences and then some really nice guarantees. The biggest guarantee is that when you submit a task that is ran, a lot of aspects of your context are preserved. So if you've ever tried to manage threads in an application server before Java EE 7, the behavior was pretty much undefined. So you might have some code, for example, that wants to look up something in JNDI, looks up a name, and then do something with it. And then what you would find is it might work, and then other times it wouldn't work because there would be a thread would be created, and that thread would not have the context information associated with your application, your Java EE application, so it would fail. So it was a very unstable thing to do, but yet there was a good reason why people were doing it. So in the spec now, it's actually fully integrated. So what happens is there's a special executor, and the application server is required to provide the same contextual information for a thread as the component of your application that's executing. So if you need to do like a JNDI lookup inside a task, that's fine. You could do that. And then when you kick it off in the executor, it'll preserve that context from the caller. And there's some other advanced stuff you can do, like you can use messaging, so you can use JMS, and you can actually send a job. You can serialize a job from JMS, and then have some code that receives this task and then executes using the context of your receiver, which is some really interesting sort of activity patterns you can do. You can think of it as sort of like you codify an action, and then you send an action to another part in your application, and then that other part of your application can then execute that action under its facilities. So that's an interesting capability as well.
Jason, can I just ask you a question?
Sure.
Okay. So something I've done, which is probably bad, is I wanted to performance test something within inside the application server. So I just did the classic thing of starting a number of threads and have those threads iterate through a number of tasks. So I just mocked something up quickly. But of course, none of the CDI stuff worked. No beams were injected or anything like that. So basically using this worker pattern, so using the batch that you just showed on the previous slide, that would work around that problem for me, correct?
Correct. Yeah. So basically, you get some common common capabilities, like you can do you can access resources, for example, like you're mentioning would be a common case where you need to access a data source or something like that. Those things would just fail all over the place, but but using this facility, it all just works basically.
So task go down an at inject, an injected field inside. Is that right?
If you're just using CDI annotations directly,
Yeah.
there's not a CDI binding that is defined by spec, but you can use like at resource, for example, that will work. So yeah, I mean that's something that I think should be added. And there's a couple of examples that are similar to this, like in JAX-RS, for example, the CDI bindings. There is an injection layer, but it is not actually the same as the full CDI capability set, and that's something that's been improved in the latest version.
Oh, so when you say the latest version, do you mean the version that's in Java 7, or do you mean the version that's going to be in, say, Java 8?
Right. I'm just saying that currently Java E7 with the concurrency utilities, you can't use CDI injections unless you did the injections up front. You can use JNDI access, and you do get at resource injection also works. And then there's your security context is propagated, but it's not exactly this. It doesn't have the same life cycle as a CDI controllable thing does, because the way the CDI works is that the injection happens when the object is created. And in this case, you're actually creating your task in your calling code, and then you submit your task to be executed later. So it's essentially like a runnable.
Right.
So at this point in time, there's not a CDI scope that's defined, but there could, and I mean, I know there was some discussions about this. There could be a scope that's a runnable scope within Executor that you could use for this. Yeah.
Yeah, I see. Okay, I can kind of see. So it's more a limitation, I guess, with possibly a limitation with CDI, because essentially you're instantiating the object using new, which is outside of the scope of CDI, so the injection doesn't occur.
Exactly. Right. That's correct.
Any object that you use doesn't get CDI things injected, does it? You have to have them.
Yeah, so you could potentially have this new task actually be a CDI bean, but the injection would happen at the call site, not at the run site, which I think is what you were talking about, what you were assuming when it would run. Now there's a ways around this problem. You know, I mean, the CDI implementation could potentially define a way to handle this particular case. And there are some APIs in CDI where you can bootstrap stuff yourself, and then you could. There's ways you could do it, but they wouldn't be a uniform or standard way, right?
I got hold of the bean manager and then created a new instance. So I did bean manager I think it was bean manager.new instance, and then give it a class name and something else, and it worked, but it was a bit nasty. I don't know whether it's if it's portable or not, I'm not sure, but it works.
Right. Yeah. You would want to really define integration there. So so in Java EE7, CDI is more pervasive, but it's not completely uniform yet, and that's actually a goal that's in Java EE8 is to improve this further.
Yes. That's the problem I have. Like with CDI, it doesn't work everywhere, and it's kind of seen as I kind of see it as the programming model for Java EE. And I expect it to work everywhere, but then you find somewhere it doesn't work as a developer, and you don't know whether you've done something wrong or whether it's literally doesn't work. And then you have a conversation like we just had, and then you realise, oh yeah, okay, I can see why they didn't make it work, let it work there. But it's still very confusing from a developer's point of view because it seems quite arbitrary at times when you can and can't use CDIs.
Right. Yeah. So there's a lot I could get into, like why that happens, but basically I'll try to shorten it just for time. But essentially, the way that Java EE specs are defined is most of the individual components of Java EE are actually defined. They're defined independently by different independent expert groups, and then it all gets integrated together at the end. And so that's actually a sort of a process challenge in getting CDI fully integrated everywhere, is that each expert group has to actually look at CDI from its particular problem space and integrate it there. So like the first step was getting the CDI technology in place as a component model that you could use, and then defining interaction in EJB. And then in Java EE7, the second step was it's now on by default. And then a lot of these supporting specs have added direct support for it. And then Java EE8, I expect it will be more like an everywhere sort of service. So it's just been something that's been an incremental thing.
Yeah.
But I could realize how that could cause confusion because you're like, well, why can't I just use this here because this is like part of the platform. So, but that's why it is the way it is.
Yeah. Yeah. Okay, we've got a question from IFC as well. So. Question is that the batch configuration seems very old school with XML. Any plans to support annotations?
Not at this point. The thinking that went into the batch, it is certainly old school. It was a spec that, like for example, had a lot of input from IBM's cases, from Spring Batch's cases, and the focus of the job specification was actually more of from the perspective of you sort of have this operational need to define a language there and then tweak it after the development of the code has been completed. So that's why annotations weren't the main priority. Although there have been discussions about defining an annotation model for it. I agree that it would be useful to have. You run into some of these sort of interesting problems with this sort of thing where what's the right composition model for annotations? You know, in a lot of cases, annotations work really well when they interact with a particular class or implementation. But in this case, where you're defining this global thing, like this job, where you have reusable components, you know, you're kind of defining all of these semantics in one place. So one of the questions we frequently come up with on the spec is, well, does it make sense to just take the XML, turn it into annotations, and stick it on a single class, and then where should that single class live, and that sort of thing, you know, or is it more of a default? So there's a lot of ideas about how that could be done, and I think it should be done. But you know, there's work to be done there to really figure it all out.
So it sounds like it's a scoping issue then, a bit like with CDI. You know, this iteration they were focused on getting a working, batch spec implementation, whereas next time maybe they'll think about usability and so on.
Yes, that's right.
Yeah. I think that probably answers the question. Does anybody else in the room have a question to ask? No, just shout out when you do, and we'll start chasing. All right. So.
Okay.
Yeah.
Yeah. So let me just move on real quick through some other things here, and I'm sure you guys will think of some follow-ups. But in the case of JAX-RS, the biggest improvement that was made that I have on this slide is there's now a client API, which is really great because you know you could do a REST endpoint and react to requests, but when you were producing them, you still had to do a lot of boilerplate code. And now you can use sort of the same pieces on both sides. So like if you write a marshaller that takes an object and puts it into, say, a JSON format, or some other data payload within your REST application, you could reuse that same object on both the client and the server side. So that helps like save a lot of code. And then there's also some nice API improvements that make it easy. So a common pattern in RESTful communication is that you need to send a URL parameter, and so like in this case we've got the actual URL contains an ID, and then we can simply define that as a template and then map that to an integer. So you don't have to do a lot of like URL manipulation code, which if you've had experience doing this before, I'm sure you've run into cases where you accidentally generate a invalid URL, like the encoding isn't properly done. And this API sort of saves you from having to deal with those hassles, because it'll always encode it correctly as long as you have a legal template. So in this case, it's just simply requesting an arbitrary object using an HTTP GET, and the payload is defined in XML format. And then from there, we use a binding layer that then takes the XML and translates it to an object. So, and it's got a nice builder API too, so you can basically just stick a whole bunch of logic on one line of code if you want. And so there were some other improvements. There's like new routing capabilities in JAX-RS, and there is some general integration improvements with injection. I mentioned this a little bit earlier in our CDI discussion, but there's more capabilities where you can inject resources as part of your REST handling code. So getting into JMS, the biggest thing to talk about here is that the API itself had a lot of code reduction as far as things that you need to do to actually interact with a JMS destination of somewhat. So now we have this notion of a JMS context. If you've ever seen code or you've written code yourself that interacts with JMS, you'll see it's like factory after factory after factory, and each factory like takes an input to a previous factory, and so it's not uncommon to have like your setup code be something like 15, 20 lines of code with proper exception handling and everything. And in this case, it's just a really simple, short, simple injection where you can define a JMS context. You can either take the default one, which points at the default destination, and then just directly send and just directly call send on it, or you can actually map it to another location, so like another connection factory, for example. So that's pretty straightforward, and really it's really just a sort of way to clean up your code, and that was the biggest improvement in the specification by far. So there some powerful improvements were made to CDI. You can now have transactional support in your CDI managed beans. So previously you had to have an EJB. So you would need to pick either a stateless session bean or stateful session bean or singleton and so on. And then you could use transactional semantics. So you could declare that a transaction, you could say transactional is required or required new for causing it to create a new transaction in the scope of a call. And all of those same facilities are now exist in with just regular CDI beans. So this is kind of nice. It just simplifies things a little bit more. And then there's also the ability that you can now have transactional scopes, which is useful. So you can have injected resources that reset every time there's a new transaction, and that can come in quite handy. I mentioned earlier that it's enabled by default everywhere now. So if you deploy a WAR, CDI is there whether you have a beans.xml or not. So what that actually means to you is that if you stick an @inject in your in classes within your WAR, it will automatically just work. You don't have to do a bunch of steps to make sure to allow it to happen. Yes?
Oh, sorry. Can I just ask you a question about the previous slide?
Sure.
So transaction scopes. Do you ever get a good use case for that? So
Right.
on the transactions team, and I was never. I understand what the purpose of it is, kind of, but I could kind of struggle to come up with a decent use case for when someone would actually want to use it. You know, like a real
Right. Yeah. Well, I think it depends on your architecture, right? Because like it's pretty common for somebody to construct a Java EE application where you have, I mean, it's incredibly common for a Java EE application actually to have the notion of performance. You receive a request for work and then you perform all the steps necessary for that work in the context of a transaction. Like that's incredibly common, right? To have that sort of pattern of processing. And so like the same thing that transaction scoped does, you can do other ways, right? You know, for example, you can get a new stateful session bean at the start of your work for a transaction, and that is effectively becomes a transaction scoped bean if you use it within the scope of a transaction only, and then when you're done with it, you toss it, right? But so all it really does is it just removes a little tiny bit of control code for resource cleanup. So you just stick at transaction scoped on your bean, and then and then you get all those injections just happen in the scope of a transaction. So if a previous transaction added something which is then referenced from your next transaction, then the transaction scope just sort of automates that access pattern.
Okay, so I suppose a use case could be, I don't know if you're dealing with a user or something, you know, maybe if you're updating the user's name, they have like, I guess the point is you have a number of classes, they're all cooperating within the transaction. So you begin a transaction, then you invoke a few different methods on different classes, and they each want to kind of share some state. Then you can kind of make sure that that state is just available within that transaction. So I'm not explaining it very well, but
yes, exactly. I mean, it's like yeah, like HTTP session, right? Like everybody, HTTP session is like this long-lasting thing, and then you've got stateful session beans, which a lot of people use in a similar pattern to HTTP sessions, where it's also a long-lasting thing. It's like multiple operations occurring. But then what people would do is they would use stateful session beans for something very much like a transaction scope, where you have a set of shared state that's only relevant for the concept of an open transaction that's being processed, right? And so yeah, so all transaction scope does is it just moves it to like something a little bit less code to write to do the same thing, but it was certainly solvable before. And I think the thought as pattern is that, well, you already have a session scope in CDI. You know, you have your standard you know, component scopes, you know, your standard application scopes, and so you're thinking, okay, well, how do I have work? How do I have state that's just associated with my current processing of work? And transaction scope is handy for just sort of being a similar mappable concept to the other concepts you're familiar working with.
Yeah, okay. Yeah, I guess I could probably come. I'm thinking about like writing a quick start for it. So I'm kind of thinking, what should the quick start actually do? Like, I guess I could probably come up with something.
Yeah. Yeah, exactly.
So I think I was trying to think of some sort of killer use case, whereas there isn't really one, is there? It's kind of it's a light convenience mechanism.
Yeah. I mean, the other thing that you could relate to is if you're using JPA, for example. JPA scopes things with, you know, when you have your entity manager,
yeah.
Entities are scoped to a transaction, right? So, like, if your state happens to exist only in JPA, then you would just use that, right? And transaction scope isn't so useful. But if you have other state that's outside of your entity model, but yet is all relevant and related, then transaction scope becomes very useful.
Yeah. So when we're discussing this on when we're working on GTA spec, most of the use cases that people were coming up with were kind of middleware use cases. So it was apparently quite useful for a JMS connection, but the end user wouldn't really see it. It would be kind of JMS that would use it, and they shared JPA as well. So kind of focusing on a middleware use case rather than an end user use case.
Right. Well, what I meant in that case was I just meant that like JPA meets the same need that transaction scope does if your objects happen to be in the database, right? But not everything is, right? Like you might have, say, a computational scope that's occurring, like you're calculating a hash code, not hash code, but like a verification code of some sort that's based off of the input that goes into the transaction. You might keep this counter around for a while. So before you would just use like maybe either just an instance of a class that you manage yourself, or you would use a stateful session bean that computes this verification code. But now with the transaction scope, you can do it within your entity bean directly and just with your CDI bean directly and just calculate it that way.
Yeah, okay, that makes sense. So kind of just carrying forward some working state. So yeah, okay, yeah, I think that answers the question.
Back to my previous point, so everything is default now with CDI, but one of the problems with enabling everything by default is that all of your types get scanned, and we have a lot of optimizations to do this efficiently. So we actually have an efficient annotation injection engine we use. We do reflection caching and all sorts of techniques to try to make this as fast as possible. But just the algorithm itself of processing annotations, it still has an input, which is the number of classes in your system. So if you had like a very large deployment that was like, I don't know, a gig of classes or something, the bean scan, and you're not actually using CDI, you might not actually want CDI scanning to happen because it could actually have a measurable impact on deployment time. And so we added some values into beans.xml where you can limit what gets scanned. So you can say, don't scan anything, scan everything, or just scan annotations that are bean defining. And bean defining means they have a scope associated with them, or they're declared as like an EJB or something of that nature. So this setting is really only useful in that case where you want to control, you want to limit the amount of scanning activity because you have such a gigantic deployment. And then there's a new feature where you can actually disable classes. Maybe in the part of producing your project, you had some experimental features that weren't, that weren't ready or whatever. You can keep the code and you can use this veto capability to disable them from injection. And then there was some technical details that were fixed with some semantics of the specs weren't defined. Like if you have interceptors that are running, like what order do they actually operate in? And so some of that stuff was further specified in the specs. So WildFly itself supports a number of IDEs. We have the JBoss Tools project, which integrates with Eclipse. We have an adapter that was written for NetBeans that's available. I believe the latest release of NetBeans includes it by default now. I'm not totally sure, but I know we had plans to do it. I'm not sure if it's happened yet or not, but there are plans so that if you're using NetBeans and you like NetBeans, that it will work with WildFly out of the box. And then IntelliJ has also added support for launching WildFly. So you can basically reuse whatever tools you're currently using and are happy with. We're running short on time, so I'm just going to kind of go a little bit faster in this next section. But the big thing is we added a new web server that was intended to meet the sort of the modern next generation of web applications, where things are there's a lot more bandwidth requirements and a lot more connection requirements. If you have a site that has a lot of mobile users, it's not unforeseeable to have several 100,000 connections. And so WildFly itself, including Undertow, was designed so that it could scale. The web server itself, we've tested up to 1 million connections with great performance. It can probably do more. It ultimately becomes a delicate balance between the operating system and the server itself. But at least on the software side, we've optimized things very well for this sort of next paradigm of development. It also has a great deal of flexibility, so you can customize just about any aspect of the server itself. You can do this programmatically by introducing handlers that can change behavior, and then you can also do it using, we have what's called a predicate language, where you can actually write rules, like something like you might think of if you've ever used mod rewrite, for example. You can do similar sorts of things and control like how requests get rejected, defined in sort of a XML format, which then gets applied automatically, as requests come inbound. And it's all, in order to support a great number of connections, it was designed around a non-blocking model. So there's no thread per connection, but at the same time we support the blocking, these simpler to development traditional blocking APIs. So like if you're using servlets with input stream and output stream, well, that's like a primary use case in Java EE, and so we support that by having the connection handling being non-blocking, but the actual code execution itself, when you're within the context of, say, a servlet that's doing output streams, then we use an optimized blocking layer for that. So there's two knobs you can tune in that area: your worker pool for blocking activities, and then your I/O pool for your non-blocking activities. And as I mentioned, there's a handler architecture. I've got an example I could show you in just a second on that. And then the project itself can be used outside of WildFly, so you can actually use like a DSL language to configure it. So let me show you that real quick. So here's an example where it's this builder API. So you just say, I'm going to create an instance of Undertow. I'm going to add a listener to listen on port 880. And here's my handler, which is going to handle a request. And in this example, it's doing, this is a purely non-blocking handler. So it actually is able to reply to the request without requiring a task to be executed in another thread. It all happens on one core that's associated with the particular I/O connection. So like basically the most efficient thread execution pattern you can ever have is when you have every concurrent action that can happen has dedicated computing resources associated with it, right? So that's where the blocking becomes a problem, right? So in the way that you can solve this is that you have a request comes in to be processed, and then you do as much as you can at that point in time, and then you switch out to another connection. So when you're executing in non-blocking mode, for example, if your computer has 32 cores, you can have 32 cores dedicated to processing I/O, and that you never have to have more threads than 32 because everything is handled in a event-handled manner, right? So that's the benefit of the non-blocking pattern. Whenever we have a blocking case, there's some other examples that you can see on the Undertow website, where what we do is we process as much as we can non-blocking fashion. So all the server actions, deciding whether or not requests are secured or not secured or kicked off or whatever, and then we kick off to another thread pool to execute your blocking actions. And then just to sort of show that it performs well, there was a third party that did a blog about, it was in response to Google sort of boasting about some load balancers they developed and how they could handle a great deal amount of requests, around 1 million requests per second, and this third party showed that, well, actually you could do the same thing with just using the Undertow project. So in this case, this performance, they did 1 million requests per second with no pipelining, and then in their official benchmark, if you do use pipelining, in this example we have 4 million requests per second, and it beat pretty much every other web server. If you look like way at the bottom of this chart, for example, is Node.js. So you hear a lot of stuff out there about how Node.js is super fast, yeah, I guess it's okay, but Java web servers have a lot more experience in performance. So when you hear this and if you're ever considering this for your application, I highly recommend you actually prototype a solution and actually see the facts yourself, and that it is possible to have way more scalability in a Java EE system than some of these new ideas that are being thought of. So the other aspect I mentioned with Undertow is we have port reduction now, so 2 ports. There's a management port, there's an application port. Sorry that I'm rushing through this because I got to wrap up pretty soon. And then the only overhead that we have is that there's an HTTP upgrade request that gets sent in. So basically what happens is if you want to do an EJB invocation or a JMS invocation, there's an HTTP request that comes into Undertow, and then it converts the socket, the underlying socket, over to the application protocol from that point on. So the overhead is minuscule, and since the server performs very well in and of itself, you won't notice a difference between going through this new model. And if you don't like it, you can actually go back to the model of separate ports for individual services. But this is the easiest way to do it, and it doesn't have much of a cost.
Jason, can I
Yes.
So you don't need to finish it on our behalf, but unless you need to leave.
Oh, okay. I can keep going. I didn't know how. What's the time limit or?
Well, it's kind of we usually try to finish on the hour, but typically I don't think we ever have. I think we usually go on till about 10 past, 4 past. So
Okay.
I don't think it's a major problem. But you know, feedback welcome. If those of you who are watching would like to be a bit more strict with the time, then let us know, and we can try and spend less time messing around at the start. Because we did start a bit late, and we kind of shied a bit, didn't we? So our pizzas are coming at 4 past.
What if I do this? What if I just quickly touch on the rest of the major features, and then I'll just leave it to whoever wants to ask questions?
Yeah, sure. Okay.
And then it can just be bound by that. Right? Okay, so really all that I have left to talk about is we have a role-based access control facility, and I can get more in details if you're interested, but basically there's a set of permissions based off of actions you can take. Like you can have somebody that only deploys stuff. You can have somebody that can only edit a section of a file. Somebody that can only see, passwords and such. And then we have an auditing capability where the actual all of the administrative changes that you make get sent to either. Let me just get it all on one slide there. It can get sent to either a syslog server, which I think this is going to be the primary case where you use it. So you have an encrypted syslog server, and then you would send your auditing traffic there. Or you can have it sent to a local file, which is protected with file permissions. So really, this only covers the administrative actions. So anytime somebody wants to change a configuration value, they want to do a runtime action, like say reset a queue or see the current message count in a queue. All of those actions get filtered into this administrative policy element. And then aspects like in your applications, like if you want to do role-based access control in your Java EE applications, we have a different solution for that that's based into the picket link architecture. And that's just because there's different semantics and rules between management and application work. So that's what this feature covers. The format itself is actually logged in a JSON record. And that's because the actual management operations themselves can actually have nested data. Like if you're defining a new configuration block, there's a lot of nested elements that would map to what that entity is. So the actual full audit gets that full record in there, so you can tell exactly what was changed. So the other big thing I wanted to mention is the minimalistic core distribution, which is just a simple 15 meg download. And this is really useful for you if you wanted to do something like, you just wanted to find like a single service, like maybe you want to do like a microservice sort of thing. You can use our minimalistic core distribution and you can either reuse one of our subsystems or write a new subsystem and have it do sort of service coordinated work from that. And then finally, there's some miscellaneous improvements we have in WildFly 8. We have improved JDK 8 compatibility. We have some extended frameworks that JBoss has. So like JAX-RS, the latest spec is there, but we also have a lot of capabilities built on top of the spec that's part of REST EZ3, and that's included in WildFly 8. Hibernate search is included, which is essentially gives you full text searches of your database, and internally this uses Lucene. If you're not familiar with the project. This used to be a separate download, but now we've actually included it as part of the platform because there was a lot of interest in it. And then you can, if you use a security manager, which is not super common, but there are still some really security sensitive users, and we now have the capability where you can actually assign different security privileges per application. So you can say like this application can connect to only this host, and this application can only connect to that host if it's doing external connections, something of that nature. And also, we removed support for CMP. So this could be a problem if you're using an old school, EJB2 style application with CMP. To move to WildFly 8, you have to migrate to using JPA. If this is really important to you, CMP support is really important to you, then I'd recommend taking a look at our commercial offering. EAP6 includes it in the EAP6 release, which is I believe has, I think, 6 or 7 years left on its life cycle. You can look it up on the website. So it's recommended to leave those legacy applications on that platform and then do greenfield on WildFly or port your applications over. And then I quickly wanted to mention that WildFly runs in the cloud, both on OpenShift, and also CloudBees has a WildFly instance that you can create as well. And we've made it to where it should be capable of running on any cloud environment. These are just the specific integrations that we know about that are using WildFly today. So that's all I have time for. That really highlights all the major features in WildFly 8, and I'd be happy to answer some questions. Let me just get to the end here. Okay.
Any questions?
So my question is, does JAX-RS 2.0 support batch requesting? For example, if I want to request get, put, and post requests into one HTTP request and send it to JAX-RS 2 endpoint, will it support this?
I'm sorry. Can you repeat that? For some reason I have trouble hearing.
I just want to know if JAX-RS 2.0 will support batch requesting. For example, I want to send a get, put, or delete into one HTTP request and send it to an endpoint in the web server. Will it support this? Or should I send these requests one by one?
Okay, so what you can do is you can use, what it will support is pipelining. The actual web server itself will support HTTP pipelining. And you can send all the requests in at the same time. Now, ultimately, what will happen is that connection will be executed in when the actual tasks come in. They'll be executed in the order they're read. So it'll read request, process request, read request, process request. But you would save the actual overhead of the network transfer. So you would optimize the network transfer essentially, but the work is still scheduled together as part of a transaction, and that's just an aspect of HTTP. The HTTP protocol itself has head of line blocking conditions. When we move to HTTP 2, which is it's getting closer to being ratified. And we are planning on doing speedy support. That this supports as well. It supports connection multiplexing, and you could have multiple requests coming in, getting processed concurrently on the same connection. Currently today, if you want to do that, if you really want to have true parallelization of requests, you have to do it. You have to issue them in multiple connections at the same time. But then you have to worry about sort of work ordering effects that occur when doing that. So you have to add aspects of that into your application.
Yep. Thank you.
Your question?
Oh, well, I was going to ask about speedy, actually. But, the other thing is maybe Jason could go into a few more details about the microservices type thing that you touched on at the end there, and the lightweight, core distribution, and what's the API? If I'm writing a microservice, is the API that sort of kicks off my microservice something like start in the subsystem or something?
Right. So essentially, what I was getting at is that so the actual WildFly application server itself, the way it's built is it's built in this modular fashion. So when we do Java EE 7, for example, we have different integrations for all of the aspects of the Java EE 7 spec. So like JPA, for example, we have a JPA integration layer, and that becomes a subsystem. So if you look at your XML file in WildFly, you'll see a list of extensions and then a list of subsystems, and each subsystem gets their own little configuration block. So normally you don't care about this because this is just sort of like plumbing of the application server, but if you want to remove subsystems, you can just delete them that way. So that's one approach to giving yourself a lighter runtime than WildFly, which is already light itself. That could be taken a step further. In the core platform essentially includes no subsystems, so you get like a 15 meg install footprint, and you can write your own subsystem with your own APIs. And the way the subsystem API looks is you basically get an entry point where you can interact with our service container, which is called MSC. And the service container allows you to define lifecycle events. So you define a service, and to define a service, you just implement an interface, and there's a start and a stop defined on that service. And we support all kinds of advanced service capabilities, like you can have eager services, on-demand services. You can have asynchronous services where you don't want to just block the method execution that's waiting for an event. You can create a new executor or something like that, pass a step back, and say that it's completed. So essentially, what you do is you write a subsystem, and then you break the things that you want to do on startup into individual services, which each get their own start and stop lifecycle, and then you could have dependencies within these services, and then the service container starts these in parallel as best it can. So it basically takes your dependency set and figures out, like, okay, how can I concurrently execute all the work I need to do on startup? And this is how we get pretty good boot times, because the container itself, when it's booting, it's actually doing lots of lifecycle stuff all in parallel. So when you write a subsystem, you get that same sort of capability. So if you wanted to write a microservice, there's two ways you could do it. You could take Java EE, you could take our Java EE 7 config, and you could strip, like, let's say you just want to do a REST-based thing for a microservice. Well, you could just take our container and you could strip out everything but Undertow and REST Easy for doing JAX-RS, and just cut all the rest of the stuff out, and then have, as part of the registration, you could just have a single deployment that gets executed, and that would be a very tiny JAX-RS only container to do your microservice. That's one way you could do it. Another way you could do it is you could write a...
Is that a war that you deployed still then?
Yes, although you could make that part of your... it would just be part of the bundle that's together, right? Now, alternatively, what you can do is you can... I showed you earlier that slide of the Undertow. Let me go back to that. Sorry. So what we have, it's like if you're using the Undertow API, I think it's right here. Okay. So in this example, if you're using, you could use an API like this. You could either reuse the subsystem itself, the Undertow subsystem, and define your own subsystem to and have it. So there's no WAR at all. You're just simply registering handles. So if you look at this slide, the portion where it says new HTTP handler, that code right there is what does the web processing work. So a subsystem can register these and associate them with a particular context or port or whatever. So that's one way you could do it. And then that would basically mean you would have a WildFly distribution with one little subsystem that's defined and one extension that's defined, which is your small service. Now, the advantage that you get from that is you would get the capabilities that WildFly has, so ability to do startup work in parallel. You have modularity, so you can have multiple separated code paths running together at the same time. But you may even go a step further and say, you know what, I don't even want that. And so, like I mentioned, our Undertow API has a DSL API, so you can have just a single jar which just does stuff. And you can even do servlet work as well. We actually have where instead of doing a WAR and then you have a web.xml file that defines where all the things are, we actually have a programmatic API where with a single, so you can have like a single Java class, and then you can say add this servlet, add that servlet, and then those classes are then picked up and wired into the container. So basically, just like a tiny jar that acts like a server. So you could do it that way as well, and then you could pull in frameworks that you use. So it depends on like which use case you're really trying to target. The point I just wanted to make is that our frameworks themselves offer the ability for you to do a very lightweight, tiny code base for like a microservice, or you can customize the server itself such that it becomes as small as a tiny microservice.
Thank you. Any questions? Yeah.
Just a question on top of this microservices. Let's say I want to make a microservice tenant aware. How can I achieve this? Is it using annotations, or should I actually put in some configurations for this?
Right. So if you want to do tenants, it depends on how you on what the contract you want to offer to Like, do you mean like a service, like a SaaS type model where it's the same application but you've got like different
Yes, you got
databases?
Yeah, that's correct.
Okay. Yeah. So in that case, there's a couple ways you could do that. So one way that you can do it is you can have actually a physical deployment that that gets bound to different locations based off of overriding the XML values. That's one way you could do it. You could also do it in a programmatic fashion. So like in this like main method sort of approach I have here, you could actually create. You could use, for example, you could create different entity managers on the JPA side per tenancy set, or you could define filtering yourself with like your own entity listeners. I'm not sure if this is what you were referencing specifically, but there was a discussion in the JPA spec where they wanted to add, or there was a plan to add a built-in tenant ID in the actual session itself, and that was tabled from EE7. I don't know if it's going to happen in EE8 or not, but if that's what you're referring to, that capability is not in.
So I was referring to actually that sort of thing. So we can, when we are creating some entity manager, assign some sort of tenant ID, so that that session is actually for that particular.
Okay, yeah. So I mean that's actually a really I could see a lot of powerful uses for that feature. So if I remember correctly, I think the Hibernate project already experimented with this capability, but it's not part of JPA. So if it exists, and I don't know if it exists right now in its current form. It was prototyped. I don't know if it's in the final code base, but you might have to use a proprietary API, like a Hibernate API, to get it. So I mean, if that's something that's really important, I mean, I'd definitely recommend talking to or raising a feature request is probably already in the Hibernate project, searching for that and then voting that up. We could potentially add that capability outside of the spec if it's not already there in some form.
Yeah. Thank you.
Any more questions? No. So I actually want to ask you a couple of questions. So one of those, so it all looks great what you're doing in WildFly 8, but what's the plan for WildFly 9? So when do you expect it to release, and what are the kind of key features that you're focusing on?
Okay, so that's a good question. So WildFly 9, we're targeting for basically into like probably fall. We haven't set the schedule in stone yet. We're just working on some key features and then sort of trying to figure out what capability set we want to tie the schedule to. We try to execute in a in a 9-month schedule at the most between majors, so that we can deliver features quickly. What I can tell you is that the next release that you're going to see is 8.2. So right now 8.1 is the current release, and then 8.2 is going to add support for CDI 1.2, and we actually have this ready to ship now. We're just waiting on Oracle to update the TCK so that we can verify compliance. There's a bunch of boring compliance rules about, you can't have something that's officially certified without having the TCK ran against it. And since the TCK is not yet updated, we have to wait for the TCK update to occur before we can officially test and certify 8.2. But that should happen this summer, and there'll be an 8.2 release for that. And then the 9 release we're targeting towards the fall, and some of the things that we want to do there are actually pretty significant. The biggest change is actually we want to split the project. So right now I talked about the core capability where there's this 15 meg distribution, but that's released in tandem with the full WildFly 8 package, for example. So like when we deliver Java EE7, that's when we do a core release. And then in the future when we do Java, other increments, like say Java EE8 or whatever, then core is still ultimately limited towards that full application release schedule. So what we're doing at 9 is we're splitting this out, and we've actually made huge progress in this already. If you look on GitHub, you'll see there's actually now a separate WildFly core repository. It's versioned separately, and then there's the everything else, and then we're going to be breaking it into multiple separate distributions. We're going to have basically a servlet-only distribution, and we're going to keep the full EE distribution that we have today, and then there will be a core distribution, and all of these different things are going to be shipped at time frames that make sense for it. So like core, we hope that we release core updates very frequently, and this is useful if you're building on top of WildFly. So it's more interesting for, say, maybe some other JBoss projects, or if you want to be more like an ISV and build something on top of WildFly's core server capabilities, then this would be useful to you because you can get bugs fixed and get updates out, very frequently, versus now where you're tied to that full release model. We're also going to be tackling some features around graceful termination of requests. So like right now, we recommend that you use mod cluster, and when you use mod cluster, you take one node out of the cluster, and then there's another node that's handling requests. Then you update that node you've taken out of the cluster, and then you put it back in, and that's how that's our recommended model right now. We've had requests for having the ability to have a single server that's not clustered that can basically be put into a graceful mode where so it's sufficiently suspended and all new requests get rejected while the existing transactions and HTTP sessions and so on are allowed to progress until to some sort of timeout and then eventually shut down. So we call that capability graceful shutdown or suspended server, and that's a big feature in 9. Another nice capability is right now mod cluster requires that you use Apache, for example, or IIS as a front end, and Undertow itself was designed to be fast enough to operate at speeds of a load balancer device. So we've actually already finished the work. It just needs to be put into WildFly. You'll be able to actually manage and deploy WildFly that covers both your load balancing needs and your actual web application serving needs and your static file serving needs all in one configured domain. So those are the big capabilities we have upcoming in 9. There's many more, and if you have suggestions on things that you think we should target, we're always interested in what your thoughts are.
Excellent. That's good. Thank you. Any more questions for now? No, I think that's everything we wanted to ask. So, was there anything else you wanted to cover, Jason? No.
Nope. I just want to thank you guys for your time. I know it's not always easy to get away from your work and personal lives to hear about, open source projects. So I really appreciate taking a look at the project. I had a resources slide that you probably saw, but then I took away. I'll try to get back to it real quick. And it basically, like, you can get everything you want to know if you want to dig further into the project on wildfly.org. On the GitHub site, it's just github.com/wildfly. We have a Twitter handle. We have a community forum. We have IRC that you can use if you want to get in and ask questions. You can talk to developers who are working on the project. Basically, we're still primarily based on the community and open source aspects, and we try to make things as transparent as possible. So we welcome whatever level of participation that you have the time and energy for. It's always very welcome.
Well, thank you very much, Jason, and thanks to those who watched. Yeah, and I'll see you later. Thank you.
Thanks.
Bye.
Bye.
Bye.